All right, so I'm going to use the jelly blubbers in front of you as my example throughout this. There are 4 major types of sampling that you have to know for this class. They're not that difficult. We just did one of them. And then the extra jelly blubber sheet I just gave you is going to illustrate the others. Okay? So the one we just did, where all the jelly blubbers were numbered 1 through 100, right? And you picked 10 using a random number generator. That is called a simple random sample. For short, an SRS, and it'll be shortened quite a bit. That is a simple random sample. It's a simple random sample because you didn't do anything extravagant. You numbered them and then used a random number generator to select them, right? That is not complicated. A lot of the time, that's the easiest way, most effective way of doing something. Now, when you do a simple random sample, everything has to be equally likely. You want every single person in your sample to be equally likely of being chosen. So up here it talks, there are many ways, that's right here, to give everyone an equal chance that still wouldn't give a representative sample. So consider, for example, a school that has equal numbers of males and females. We could sample like this. Flip a coin. If it comes up heads, select 100 female students at random. And if it comes up tails, select 100 male students at random. Everyone has an equal chance of selection, but every sample is of only a single sex. So that is not representative, right? So when I say equal chance of being selected, you don't end up being somebody. That's why it would be easier to just take this entire school and number everybody, and then select random numbers instead of trying to do some shortcut like flip a coin. That ends up with problems. So generally, simple random sample, you just and select digits. The simple random sample is like the basic unit for every other sampling method. All right? So we just did a simple random sample. So do you understand where that came from? Or what that is? Yes. All right, the next one. This is new. It's a stratified sample. Now, a stratified sample you're going to use if you know that different groups are going to have different opinions. So for example, let's say I'm going to ask a survey question that I just know males are going to answer differently than females. And let's say that in this school that there are way more males than females. That may or may not be true. I'm just saying for example. Okay? If I do a random sample, there's a chance that I'm going to get more males than females, right? There's a chance I could get all males and no females. I could get all females and no males, right? If I did a simple random sample, it could happen. But I know ahead of time that these two groups have different opinions. So wouldn't it be nice to split those people into groups first and then sample from the groups? Then I guarantee to have the opinion of both of those groups. That's what stratified sampling is. So first, you slice your population into groups, and they're called strata. And then you use a simple random sample in each strata. Or stratum for short. It's for singular. Okay. But so here's a really great example of that for Murray High School. I'm going to do an opinion survey about something. But probably freshmen and seniors definitely are going to have a different opinion because seniors care more than freshmen. True? So I'm going to split the school into freshmen, sophomores, juniors, and seniors. And then I'm going to number all of the freshmen. I'm going to number all of the sophomores, all of the juniors, all the seniors, 1 through whatever, all 4 of those groups. And then I'm going to select like 20 from each grade. All right? That guarantees that I get the opinion from each one of those groups. Does that make sense? So on the jelly blubber paper in front of you, the new one I gave you, it's already split into size for you. It's in 5 different size groups, right? So I could, if I wanted to, they're already numbered within each group. So I could pick 4 from each group randomly. So I would do, like, the first one I think is 1 through 19. So I would do 1 through 19 4 times and pick 4 of the little ones. Then do 4 for the next group and 4 for the next group, and et cetera, right? And then I could average all of their sizes. But then I would have a definite representative from each size group. Everyone know what stratifying is. The big advantage to stratifying is it reduces sampling variability, because you guarantee that you have an opinion or a measurement or whatever from each group. So there's less random chance about maybe getting all the big blubbers when you do random numbers or whatever. Okay? Does that make sense? All right. I'm making this a big deal because the next one sounds similar, but it's not the same. Okay? The next one we're looking at is a cluster sample. In a cluster sample, you're still going to split your population into groups. But once you split it into groups, you are going to do a census of one or more of the groups. So you're not splitting them into groups and then selecting a few from each group. You're splitting them into groups and then selecting a few groups to ask everybody in that group. Okay? So think about your jelly blubbers in front of you. If I'm doing a cluster sample, if you notice, each size group is numbered out to the side. There's Roman numerals 1 through 5 down the side. Everyone see that? If I was going to do a cluster sample, I would randomly select maybe 2 groups. So I would do random number generator 1 through 5 and pick 2 numbers. So maybe I get 3 and 2. All right? Well, then I measure every single jelly blubber in group 2 and every single one in group 3, and those are the only ones I measure. So back to my Murray High School example, I split the school into freshmen, sophomores, juniors, and seniors, right? But then I numbered them 1 through 4. So I end up getting I just want to survey one group. So I generate a digit and I get 3. That means I'm asking every single junior. I'm not asking anybody else. Okay? So you're splitting into groups for both of them. For a stratified sample, you split them into groups and survey a few from each group. For cluster sampling, you split them into groups and you select groups randomly to do a census of. So you ask everybody in that group. Do you see the difference? I have one more illustration to help out with that. The book has a really good example. The book uses a Boston cream pie as the example. If you're not familiar with Boston cream pie, you're missing out. Boston cream pie has a chocolate layer, it has a cake layer, then it has a custard layer, and then it has another cake layer. It's amazing, right? Let's say we're doing a stratified sample of the cake. So stratified sample of the Boston cream pie, I would be taking slices, right? I'm going to slice into the cake, so I have all layers represented, right? Every slice is going to have chocolate cake, custard cake, right? So that would be stratified.
Wait, I thought stratified you put them into groups.
Yeah, so you'd have a group, you'd have chocolate, cake, custard cake.
Yeah, there's 4 groups.
I know, so you take a slice, and all 4 of those groups are represented in that slice, right? If you wouldn't be doing slices, all right? You'd be sampling single layers or something. So for a cluster sample, maybe I number these 1, 2, 3, 4, these layers, and I use a random number generator, and I end up getting a 3. That means all I'm eating from the Boston cream pie is the custard, and I'm eating all of the custard, right? But I got no cake and I got no chocolate. That is really unfortunate in the scenario of the Boston cream pie. But that's how it works, okay? So stratified, you get a little bit of each group, and a cluster sample, you get all of one layer. Okay? Yeah? Okay. And then if you combine multiple methods, you get a multi-stage sample. So maybe I split the school into groups, right? Freshmen, sophomores, juniors, seniors. And I do a cluster sample. But then within the cluster sample, I do something else. Like there's just more layers, all right? And so that doesn't come up very often, but there's just more layers. All right, one more sampling method. Multi-stage is not like super important. The last one is really easy, different from the rest of them, so it's really easy. So the last one is a systematic sample. And systematic means there's some like method to your madness. Like you're going to survey every 5th person on the class roster. Or you're going to survey every 20th person on the school roster. If you're doing the jelly blubbers, I'd probably go back to the first page and like measure every 5th jelly blubber, right? But there's some specific method, like you're defining, I'm going to look at this many per this many or something, okay? Or I'm going to survey every 3rd person that walks down the hallway. Or I'm going to survey every 3rd freshman that walks by me. That way I'm not being biased. Okay? Does that make sense? Systematic. All right, so you have a reading quiz tomorrow. I'm getting ready to give you the pages. You're reading the exact stuff I just gave you, but it's important that you read it to make sure you got it. At the end of the reading section, there's a just checking part, all right? The just checking is what your quiz is going to be like tomorrow. Since I already gave you a scenario, like all these scenarios, I've already defined them all for you, we did an activity today, your quiz tomorrow will not be definitions. Your quiz will be, here is a scenario, which sampling method did they use? Simple random, systematic, stratified, or cluster sampling. So the just checking answers are on page 291 if you wanted to try that and practice.